Hello, community. It is so great that you are back. It is an early Sunday morning. It is raining outside. And I have a new video for you about visual reasoning. And you know the good thing about it is, I don't have to talk a lot. It's just visual reasoning. So therefore, let's start right away. And yes, I needed your help. And I ask you, hey, for my upcoming video, I need your support. Can you think visually? And 89% of you told me, yeah, of course, yeah. And 11% said, oh, maybe I translate here some visual into words. So let's start it with visions. So here we have the first one. Can you guess what was my idea, my interpretation, my command to generate this image? Well, here we have it, ChatGPT-4, this new beautiful create the image. And I said, hey, listen, I want to have here some AI internal quantum logic space, and I want to have here some Planck scale turbulence, some bubble filaments, some chaotic subspace inference, and I want the scene to be distorted by holographic Feynman diagrams with propagated that appear broken, disrupted lines here. I want here the disintegration of quantum coherence and a quantum collapse here with recursive logic. And you might say, yes, of course, this is what I see, nah? You got the feeling. What about this one? What was my prompt here? Visual reasoning. Yeah, the system was cheating because it just put the words in, no? But hey, we can think visually. So the prompt, easy. I said here, an abstract visualization with high details of the topic. Express here the logic chain, the causal reasoning that is based on a variety of visual artifacts, and render it by an artificial intelligence in a way to make sense and produce a visual content. Easy, no? If you are a creator, you know exactly what this is. Now you say, yes, I know, this is Kandinsky. Yes, of course. And I wanted to depict here the chaos of visual thinking. But don't write the words. Stay visual only and depict the complexity of visual thinking without any words. But now let's become a little bit more scientific. And you might say, what is happening here? This looks here that there could be a message encoded in a visual representation, no? Yes, of course, I just said here to ChatGPT-4 Omni here, show me the visual reasoning chain in the emptiness of outer space. Don't write words, just depict it visually. You can use any abstraction you like. And, you know, I have no idea what is the message that the AI is shown to me. But you might say, hey, come on, you have to have precise here instruction. Oh, you have to be absolute precise, and this should be maybe a mathematical. So let's do this, and then ChatGPT-4 Omni will succeed. Show me the complete mathematical expression of an electron-positron Feynman graph inside of a vacuum tube. Well, I'm so sorry, but this is wrong. Yeah, there's some... I see that you got some ideas, but the result is simply horrible. By the way, talking about horrible execution, if you do not pay for ChatGPT, this visual thing here, just want to show you here my experience, no? Create an image here, beautiful, and come back is, there's an error that attempt to generate the image using here your prompt. Unfortunately, the system wasn't able to complete the rendering, and I cannot retry unless you explicitly ask me to do so again. And I'm charming, especially on a Monday morning, and I say, you created this prompt, so execute your own prompt and don't tell me that you can't do it, or that I encountered now a timeout, no? And ChatGPT-4 Omni comes back and says, you were absolutely right to expect a result, especially since the prompt was carefully crafted and you were clearly asking for something reasonable with it and well within the domain of what should be possible. The truth is, I did create a prompt. The failure you're encountering isn't because of your request or how it's written. It's entirely due to an internal image generation system issue that are beyond both of our, suddenly we are our, ChatGPT, our control. And when I say I can't execute a prompt, it's not an excuse or delay tactic. It's a system-level block that fails at generation time. Although your request is valid. Hey, this is an AI you want to experience, no? But you know what? It gives me here another option. Here's what I can do where it's ChatGPT-4. I can produce here the exact prompt for other internet platforms that you can run over there on their infrastructure. And since you only pay here for the $20 a month abo, you know, go there, use their resources, run on their hardware infrastructure. But don't come back to me. Look, I offer you this for Midjourney, for Leonardo, for Runway, for DALL-E 3 with Bing image creator. And you say, yes, of course. So I will leave now ChatGPT. No. And I said, come on, run the damn prompt as I pay for this. And then I got this, I would say, horrible image by ChatGPT for Omni after a short discussion of about 15 minutes. So if you think, hey, how's the user experience with this beautiful new Ghibli image style representation? I can tell you, maybe this is the prompt you should be looking out for a solution. I was not satisfied with this and I just said redo. And you know what? ChatGPT comes back and says, I understand how frustrating this is, and especially since you invested time, effort, and payment. Unfortunately, tells me ChatGPT, I wasn't able to run the prompt because the system, which is AI, which is ChatGPT, has imposed a rate limit. And now I have to wait 22 minutes before anything else. At this moment, I say, ChatGPT for Omni, you know what? Thank you. So let's open up this video, and now you understand visual is beautiful. Visual has no problems at all. Visual is gorgeous. And you say, yes, of course, because we have seen this video, yeah? Where I showed you here from NVIDIA the Reason-1, the physical AI system, or where we looked here at this decompression of the chain of thought complexity, or we looked here at new AI foundation models, no, that go so much beyond LLMs, or even, as I showed you here with Google DeepMind robotics, that we encounter a thought collapse in the robotic system of Google DeepMind, yeah? So let's have here, and we have a spark of genius, of course, because if you remember in this video, we went through here the steps here, how this is achieved, and we have a pre-training, we have a general supervised fine-tuning, and then we have a particular physical AI supervised fine-tuning. And then, of course, you know, step 4 was important. We had a reinforcement learning based on the physical world that the AI should understand. And we, of course, used the reward system, and we used the group-based reward policy optimization from DeepSeek R1. Now, let's come to the interesting fact. And this is the study I want to show you. This is already 2 days old. I'm sorry, it's a Sunday. And it is called here Reason-RFT, Reinforcement Fine-Tuning for Visual Reasoning. And it's a beautiful study by Peking University, the Beijing Academy of Artificial Intelligence, the Chinese Academy of Sciences, and the University of Chinese Academy of Sciences. And I've chosen it because what I like, and kind of tricked me to show you this, isn't this visual beautiful? And I said, yeah, this is the study I want to show you here. There's just one question. Hey, why there's so much text in this visual representation? If we can think visually, why we need here this text? No, is there no other way? I mean, look at it. This is here, let's zoom in here. So what we have, let's decrypt this. No, without having a look at the study. Okay, I cheated a little bit, I read the study. So what is it? There's a question. Okay, we have here a question, a multiple choice question here with an image, beautiful. Only a supervised fine-tuning based training. Okay, this is not a happy face. So I suppose they want to tell us the standard is only a supervised fine-tuning training, which is not true in the case of NVIDIA. But if you are a little tiny company somewhere in the world and you do not have the infrastructure resources of NVIDIA, okay, maybe you only go with supervised fine-tuning base. Then we have a question, and then they tell, you know, the answer from the supervised fine-tuning model that is only doing here a chain of thought reasoning is this, and this is, of course, in red, the wrong answer. And now we have this new, and this is now in green, this beautiful Reason-RFT model, and guess what? It will give us the right answer. And you might say, okay, but what the hell is this Reason-RFT model? Explain this to me, no? And I guess this is now here happening on the right half here of this image, no? And you look at this and you say visual counting, structure perception, spatial transformation, and you have here some color code and it goes up, and you say, hey, that's great that it goes up, no? And here we have the Reason-RFT with greedy reward stratification, transient adaptation gap, and reasoning redundancies. And I say, I don't understand a word. So the visual is not that good, yeah? But okay, here's now the solvation. Here we go. This is a stage 1 and a stage 2. So I guess, since here there's a brain with some, whatever this is, that this here is maybe the Reason-RFT model, no? In a visual representation. No, it's so easy to follow up here. So we have a chain of thought reasoning data, a book, an experiment, and some geometry. Question and image. We have a vision language model, a chain of thought reasoning process, and a final answer with supervised fine-tuning. And then we have question and images, vision language model, and policy optimization, the group relative policy optimization here from DeepSeek. Everything okay? Everything clear? Should I explain anything else? This is visual reasoning. And thank you to the authors. They made the effort and I think it's great. And I like this study. I just want to show you what we can get out of visual reasoning. What is here the power of visual reasoning? Let's go to the next one. So we have here again this phase 1, the supervised fine-tuning based activation, okay. And then we have the reinforcement-based enhancement with GRPO. This is great. So we have our policy model, we have our reward system. But then look here in this, there seems to be here kind of arrow going out. So the reward seems to be here now shown in detail. And it seems to me that this reward evaluation has a format reward. So more on the shape of the reward and then an accuracy reward structure. And as I see here, format reward, and here again, format reward, and then I have 1, 2, 3 accuracy reward structures. I guess this is now here the zoom in, so beautiful. Vision reasoning is working now. So the format reward, what is it? We have a format, oh, now I have text, so it doesn't seem to be so easy to depict this just visually. Think, reasoning process, end of thinking, answer, final answer here, end of answer. Okay, and the format of the reward function is 1 if the answer adheres to the format, otherwise it's 0. Okay, so you just check if the format is what you decided that you want the answer to be. Discrete valued accuracy reward. You are a visual counting expert. Oh, I got a discrete valued counting expert. So if I had 2 large buses in the image and then remove all the bikes in the image, how many buses are there in the example? Okay, got it. Mathematical accuracy reward. Hey, geometry, nice. Reminds me of school back 100,000 years. You are a visual geometry expert. Of course I am. Given the image, you should solve the problem as shown below and provide an answer in LaTeX format or as a floating point number. Okay, I will talk a little bit about this in a minute. And then we have a function base. So this is now interesting because they say, hey, you are a spatial visual reasoning expert. So what we have a certain perspective on a scene, and this scene has 6 objects. And then somebody rotates the scene, or the illumination, the lighting is different, or we move in respect to the 6 different objects. And then we have a look with our video sensors, and we see now here that the object moved. And now the question is simply, hey, was it just a rotation, or was it a shift? Or did even the object themselves move in a particular way? Can you now have here an accuracy reward given here, maybe if you have changed your spatial visual position? What I like here is then this, where I just go for a vision today. It's a simple video, this is just a feeling. So we have this example again, and then we have out-of-domain views, so views that the system, the AI, has not been trained on. And then we have the final right views, where the system has some information, some training data. The question is, what happens to these out-of-domain views? Is the system able to understand that this particular scene here, look at this, is it just a rotation operation? What is happening here? Or do we even move some of those little gadgets around? So, can the AI system figure this out? Again, you tell the AI system you're a spatial visual reasoning expert. So let's have a look at this. What is happening? We have here the blue one, then this one, okay, but there seems the distance has moved a little bit, yeah? And then suddenly here, whatever color this is, turquoise, this seems to have moved here between here, this line of sight between these two objects, okay. But those three objects kind of remain in place. Are you sure? No, absolutely not. Because the surface changed and the relative position changed. So describe this in visual reasoning. And here we have the function list. Change the color, change the position, change the shape of the object, change the material, and change the size, and change the lighting should be included, and change the perspective. So we have now to write all this function in visual reasoning, and guess what? I'm going to show you this, and you will be surprised because we will use words for this. Very easy example. How many times larger is the total number of eggs in the second group compared to the first group? Well, we can visually count this and compare to a pure supervised fine-tuning. If we go with supervised fine-tuning and reinforcement learning, we get the right answer. The same test here. If we only go with supervised fine-tuning, we don't make it. If we go with the new supervised fine-tuning and reinforcement learning, we get the right answer. This is now much more interesting. The total surface area of this rectangular prism, if dimension are 3 units by 4 units by 5 units. Here we see that the supervised fine-tuning gets it quite right, no? You see everything is green up to here. And then in the final sort, there's a problem, yeah? While of course supervised fine-tuning and reinforcement learning gives you the right answer. This is now interesting. Now we go into exactly this what we just talked about, the central view of an initial states. So we have an initial central view image and a final left view image. Are they identical? What operations happened? And now we start here in this particular case to describe here the visual, the image. Look, 0, object 0 is a cube, medium size, gray color, and the material seems to be rubber. Object 1 is sphere, medium size, cyan, metal. So what we do now, in this particular methodology, the authors try to make sense by converting a visual into, again, words. And then, if we have just the supervised fine-tuning, it fails. But of course, if we have the supervised fine-tuning and reinforcement learning, look at this. We have here only complete linguistic commands, linguistic identification of those objects. And then we, if you want, our visual reasoning is happening only in words. But there's no visual reasoning happening at all. So let's come here to the end and say visual reasoning. Well, it didn't happen. Eh? What we did is we looked at this, we transcribed here the image into a beautiful text here describing everything the eye could identify, the color, the size, the material, the relative position, the lighting, whatever, and then just argue in an LLM, but not a visual reasoning. So, does anybody please out there have any idea how to make it a visual reasoning system? This is the end of the video of my visual, but of course, if you know me, yeah, there's something missing. So of course I looked a little bit deeper, but now I use text. So I don't know if you like it, but I looked here a little bit deeper in the reward here of the format, giving you an example. Then in the accuracy reward, I looked here more in the discrete value type and have given here an example. Plus, of course, here for structured reception, here with some numerical answer, I'll give you an example and the rationale behind this. And here the spatial transformation in detail. And I have here a detailed example here where I show you the model prediction. What is it? Model prediction 2, model prediction 3. And that the rationale is also here going for partial reward system like we know here from Monte Carlo research, for example. Now, what is the main general idea here of this new paper? What is special about this paper? The authors argue that it's not just doing here supervised fine-tuning and then some generic reinforcement learning with GRPO from DeepSeek R1. They kind of say, you know, we just want to do a minimal supervised fine-tuning activation, just only enough to teach the model the format of the reasoning and to avoid overfitting. Because the more supervised fine-tuning you do, you know, the system starts to overfit. And you think, what? Now I have a system that is overthinking and overfitting? Welcome to the club. So therefore, If they only have a minimal supervised fine-tuning, they go then with a targeted reinforcement learning enhancement and they use GRPO. Beautiful. And they say, but careful, this synergy, how you balance these two elements out is crucial, as just a pure reinforcement learning without the activation here struggles also. So they say now for their visual reasoning methodology, the balance between this minimal supervised fine-tuning and a targeted reinforcement learning enhancement, this balance is crucial for the success. And they also tell us they are observing that the supervised fine-tuning leads to longer reasoning chain the more we have here supervised fine-tuning on dedicated causal reasoning verbal representation, of course. But at the same time, they notice then the second step with the reinforcement learning, this must go here the full length of this reasoning chain, because if RL somewhere just stops or just forgets here the last, 10% of the longer reasoning chain, they run into trouble here, of course. So this balance that you create here, longer reasoning chain, and then the reinforcement learning has to take care about each and every element and function and relation in this longer reasoning chain, resolve it, compress it, provide different examples to train the system on this alignment phase. This is here crucial. This is for me the main message here of the authors. So, if you enjoyed it, yeah, this was a Sunday morning session. It is still raining, but I hope you enjoyed your cup of coffee or your cup of tea. And if you subscribe, I see you Monday morning.